Hi class, we are going to discuss virtual functions. So there's a slicing problem. What is mean by slicing problem? So let's say that we have declared a shape and then a square object, and then we are going to assign one to the other. Which way is actually possible? Square equals to shape or shape equals to square. So the one that is legal is the shape equals to square, because if we think about the that square has, and so it's kind of well, there are more members in member variables in the square, but less in the shape, and so it's easier to cut off certain things and make it possible than have to invent something that out of thin air. Basically, you can think about it that way. And so shape equals to square is legal. And what is slicing problem? Basically, because whatever data that belong to square that shape doesn't have is then become unavailable. So that's why we want to talk about how to make extended type compatibility happen. So even with that kind of assignment, we actually can make the data of square still being available using two components. One is a dynamic variable and then virtual functions. So basically, our goal is to indirectly access the extra data that a square minus a shape has. Let's look at this example. We are implementing a new function called draw. We are drawing the shape, but we make it a virtual function. So how to make it a virtual function is to add the keyword virtual, just like we add keyword friend before. In the case of rectangle, we also have this virtual function called draw that we are going, it's kind of like we define, but in the back end it's not, and also in the way we are using virtual function is not. And then in square, we are actually not implementing that draw function, even though in the main function, when what we are drawing, it's in a way a square, because we are pointing to a square. So let's look at this main function line by line so that we understand what we are trying to accomplish. We declare a square object with side length equals to 5, and then we are not using pointer in this case to show you how it doesn't work without a dynamic variable and the virtual function, or without just the dynamic variable. So we also declare a shape object called shape, and then we assign it equals to square, and then we would call shape.draw and see what happens. And then we would declare another shape object called shape2. We would assign it to equal to the address of square, so it's the same basically object, and then have shape2 point to draw and see what happens. So let's look at the code. We have implemented the rectangle : draw here by basically printing out a star to so if the length is 5, then we would print out 5 stars, and then if the width is 5, then we print out 5 lines And then we actually didn't implement the, well, in the shape we did. We actually have it print out. I don't have any information to draw yet. That is what this shape virtual function does. So let's so this is exactly like we just discussed in the main function. And we are going to run the code. And you will see that the first call of the shape.draw, it of course just call the one that is directly in the shape class definition. And so that's why you print out I don't have enough information to draw yet. And then the second one, using the pointer, it's actually able to access the shape 2's or the squares information and then draw appropriately. But I think one comparison to do is very good to show you how it's different if we don't use the virtual keyword. So we deleted the virtual keyword from both cases, and then we would compile the code and run it again, and you can see that in both cases it actually will just call the draw that belongs to the shape class. So if you look at what we did in our example, we actually have the virtual keyword in both the declaration of the draw function, even though it's not required, but it's a good practice to have that virtual keyword in front, so to remind us that we are using it as a virtual function. Virtual keyword is only required in the base class to make a function virtual in all the other classes. Another thing that we want to discuss is that destructor, in the case when we are using dynamic arrays and virtual functions, it's better to make all the destructor virtual as well, because if we think about how virtual destructor works, in the case of shape, pointer of a shape equals to a new square, for example, if the destructor is not virtual, only the destructor of shape is being called. But in terms of square, it's okay because there's no members. But in terms of there's still rectangle that is ancestor of square, right? If rectangle has any pointer variables or virtual dynamic variables in there, then the destructor of the rectangle is not being called, and then the cleanup is not being completely clean when the shape 2 goes out of scope. So if you want to really understand better about why, I have included this link, the difference of between how virtual and non-virtual member functions are called, has a good discussion of why the virtual function behave the way it does. It actually will look up a table when a virtual function is being declared, basically. And I think it's good information, but it's not required, and I don't want to make it more complicated for you to explain it here. But if interested, look at that link. So you might ask, why are we making it so complicated? Why do we have square equals, I think it's a shape equals to a square, right? A square being assigned to a shape. Why is because, for example, there may be cases that you want to have an array of shape, and then you can do things or print out all the using calling the draw function in all the shapes. It can be rectangle, it can be square, it can be circle, it can be ellipse. And so with virtual function, then it can be possible. Like we demonstrate without the virtual keyword, if we call just the draw, it will always go to the one that is being so we can't, like, we would have to specify which version of draw to call. But in this case, we can always just arrow to the draw function, and it will call the correct draw function appropriately. So to recap, what's the difference of virtual and redefined functions? The declaration and implementation are almost exactly the same in the two cases, the virtual and the redefined, except that the virtual keyword has to be used. But in terms of virtual function, actually the implementation of the function is not being bounded until runtime, which is called late binding. And that is the difference of virtual function and redefined function. So because of the extra work that is required of the compiler and the runtime environment, virtual function is considered less efficient. And also, if there's no reason, we don't really want to use it. So all in all, what we are saying is that virtual function is different from redefined function in the background more than in the foreground. This is actually related to polymorphism, which is the ability to associate different implementation to one function name by the way of late binding, which is also a key component. Basically, polymorphism, I think in the beginning of the semester, we talk about it's one of the reasons why we want to use OOP, object-oriented programming. And I want to mention that basically virtual function, late binding, polymorphism, it's kind of the same concept. So to recap, we talked about what is virtual function. We talked about how virtual function extends type compatibility, and then polymorphism, late binding, and OOP virtual functions relationship.